Welcome to my first video on thermodynamics. In this video, I'm going to talk about the basic concepts of thermodynamics. What is thermodynamics? Why it is important to study thermodynamics? I will also explain some of the basic concepts of thermodynamics with some real life examples. Okay, what is thermodynamics? The very basic and simple definition of thermodynamics is the study of energy transfer and its effects. Energy transfer means we are going to study about heat transfer and work transfer. We are going to study about how we can convert heat into work and also work into heat. Effects means the property changes that are happening due to this energy transfer. Property changes of a substance or a system that is undergoing this energy transfer. What properties we are going to study? Temperature, pressure, enthalpy, entropy. Energy itself is a property of a system. Let me explain what do I mean by energy transfer and its effects. Here I have a piston cylinder device and my point of study is the air inside this cylinder. At condition 1, air is at 20 degrees Celsius and its volume is 1 meter cube. Now if I add some heat to this air by using some external source, what will happen to this air? The air will expand, its volume will increase, as well as its temperature will increase. So at condition 2, air temperature is 80 degrees Celsius, its volume is 4 meter cube. Now if I want to relate this example to the basic definition of thermodynamics, I will say the mode of energy transfer is heat, and effects. What is the effect of this energy transfer on the air? Increasing temperature and increasing volume of the air. Let me explain the work transfer example. Here I have a piston cylinder device and my point of study is the air inside the cylinder. If I apply some force on this piston will compress this air. So this is an example of work done by the piston on the air. What is the effect on the properties of the air? Its volume will decrease and its pressure will increase. So if I want to relate this to the basic definition of thermodynamics, I will say energy transfer is a work transfer. Effects on the properties of air, decrease in volume and increase in pressure. Okay, why study thermodynamics? Why it is important to study thermodynamics? Thermodynamics is necessary to design mechanical systems. We use laws of thermodynamics to design energy efficient mechanical systems. So as a design engineer, we will use laws of thermodynamics to design different systems. In second law of thermodynamics, we are going to talk about the energy losses. When we are converting heat into work, there are some energy losses. It is impossible to convert 100% of heat into 100% of work. So as a design engineer, when you are designing a car engine, a car radiator or a refrigerator, you can consider those energy losses. What are the basic examples of the systems that works on the basis of thermodynamics? Refrigerator, air conditioning system, car radiator, car engine, steam power plant, steam boiler. There are many examples. Air conditioning design example. We all have seen air conditioning systems. Inside this air conditioning system, there is a working fluid called refrigerant. The role of this refrigerant is to flow between indoor unit and the outdoor unit. So the indoor unit receives cold refrigerant. The indoor unit coil receives cold refrigerant from the outdoor unit. This cold refrigerant will absorb heat from the room air which flows over the indoor unit coil, and the room air will be cooled to a particular temperature. The refrigerant then goes back to the outdoor unit and rejects that heat to the atmospheric air. So basically, refrigerant picks up the heat from the room air at the indoor unit and gives up that heat to the atmospheric air at the outdoor unit. This way, air conditioning system maintains a particular temperature inside the room. Okay, getting back to the question of why it is important to study thermodynamics. For this example, to be able to design this air conditioning system, you need to understand the process of heat transfer that is occurring between refrigerant and room air and between refrigerant and atmospheric air. So you will use laws of thermodynamics to calculate heat transfer at the indoor unit, heat transfer at the outdoor unit, and that's how you decide your cooling capacity of the system. The next thing, you will calculate the power consumption by the system to deliver this cooling capacity. Next thing, selection of refrigerant. So you will study the properties of refrigerant, which requires the basics of thermodynamics. Next thing, you will select size and material of the coil. As an engineer, you will decide what size of indoor unit and outdoor unit coil you will use, what type of material of the coil you will use. You will study the thermal properties of the material, and lastly, airflow. For selection of airflow, you will have to decide how much airflow is required to deliver that cooling capacity, how much airflow is required to cool down a particular room volume. For selection of airflow, you must have a basic understanding of thermodynamics, which is understanding of convection, natural convection, forced convection, basic understanding of fluid mechanics,